Alright, today we're going to be working on activity 3.7, statistical analysis with Excel. So the first thing I want you to do is to open up Excel, and we're going to open up a blank workbook here. So double click a blank workbook. In cell A1, I want you to put the activity, so this is 3.7, statistical analysis using Excel. Okay, and then in A2 I want you to put your name. Now, we need to create the table that we are going to make or use our data, use to calculate our data. So we're straight from 3.7. They give you these numbers. So go ahead and label your data. So we're going to use connector sample number as the heading for our first column, and then the heading for our second column is going to be depth in centimeters. Now right now it looks like it cut off the first column there, but if you come up here between the A and the B and you have this black arrow and you just double click, it will change the width of that cell to match your longest one. Now really I don't want it that long, I want it to be more like right there because I don't care if this first one carries over, so I'm going to change that back. Okay, our connector sample number are just numbers 1 through 12, so we're just going to number that 1 through 12. Okay, and then the depth of those samples is in centimeters, so notice that I did put centimeters, and you can tell that this is carrying over a little bit too, so I'm going to go up here between B and C and double click, and that will change the width of that cell as well. Okay, so I'm going to enter in my depths that they gave me in 3.7 here. So we've got 3.8, 3.9, we got 2 of those, and then 3 4s, and then 4.1, there's 3 of those, and then 4.2, 4.3, and 4.4. Okay, so all of our data is entered, and that's what we're going to calculate everything off of. So the first thing we want to do is calculate the mean of this data. In Excel, we're going to use formulas instead of having to calculate this by hand. And anytime you use a formula, you want to use an equal sign. So in cell E4, I'm going to type in equal. And then the command to find the mean is average. So I'm going to type in average, and I'll double click, and I just want this first one, not all of these, so I want to double click the first one, and there will be a parentheses. Now you have to tell Excel what you want the average of, and I want the average of all of these numbers here, so I just want to highlight those numbers, and then I'll close my parentheses and hit enter. So our mean is 4.06 repeating. You can change, like if you want to round that to 2 decimal places, up here you can change how many decimals places. So see, that's giving me more, or I can make it less. So if I want 2 decimal places, I can go until there's just 2 numbers after the decimal. I'm going to make that column smaller, so I'll double click between E and F and make it smaller. And I can even make D smaller, so double click between D and E and make that smaller. So next I want to calculate the median. And the command for median, again, remember to use an equal sign, and then the command for median is median. So I'll start typing median, I'll double click, and again I want the median of those same numbers, that same data. So I'll highlight that data, close my parentheses, and hit enter. So the median is 4.1. Now I want to find the mode. So I'm going to label this mode and come over to E6. Now, if I'm not sure if I have more than one mode, the best thing to do is to maybe highlight several blocks, because maybe I have 5 modes. Now you can look at this data and tell that you only have 2, but if I didn't know, I would highlight a bunch of blocks, and I'm going to type in the command equals mode, and multiple modes mean there's more than one. So I want to use the command equals mode multiple. So double click that one. Again, highlight the data. But this time, because there's more than one, we're going to hit, instead of just hitting enter, we're going to hit Control-Shift-Enter. Now, you can tell it only brought up 2, and it's showing that these other 3 that I had highlighted, that's not applicable. That's what NA stands for. So that means that there's not more than 2. There's not 5 modes, there's only 2. You can't delete those, by the way, so you just leave those there. Okay, next thing I want to highlight is to calculate is range. Now in Excel there's not a command for range, so we kind of have to know how to find range. Remember, range is the highest number minus the lowest number. We can make Excel find the highest number by using equals max. So the maximum is going to be the largest number of this data. So I want Excel to find the max of this data, so I'm going to highlight that and hit my close my parentheses. But I don't just want it to find the max, I want it to find the max and then subtract the smallest number, and the command for smallest number is minimum. So min, double click that, highlight the same data, and then close your parentheses and hit enter. So what you're telling Excel here is take the maximum number out of this data and subtract the minimum number out of this data, and that will be the range, and that happens to be 0.6. And sure enough, the highest number is 4.4, the lowest number is 3.8, and if you subtract those numbers you get 0.6. Okay? The next thing we want to do is find our standard deviation. Now remember, there's 2 standard deviations. There's standard deviation of a population and standard deviation of a sample. And there'll be 2 different formulas for that. So I need to double click here so that my cell is big enough. So the standard deviation of a population is equals ST, and then it's DEV.P. So this one right here, double click, highlight your data, close your parentheses and hit enter. Then we'll do the sample, ST DEV.S, so it's this one, double click, highlight your data, close parentheses, enter. So not a lot of difference between the 2 standard deviations. I'm going to make my standard deviations go to 3 decimal places just to make it a little bit more accurate. Now remember, we need standard deviation in order to find out what our acceptable minimum and maximum is going to be. So we can now, this company can now tell, based on the standard deviation, what the minimum and maximum acceptable measurements will be for these connector samples. So the minimum acceptable depth, we need to calculate that next. The minimum acceptable depth is equal to the mean, so I'm going to hit equals, and then I'm going to click my mean, and it's going to be the mean minus 2 standard deviations. So I'm hitting equals mean minus 2 times, and then I want the sample standard deviation. So I'm telling Excel to take the mean, which is located in E4, and subtract 2 standard deviations, which is located in E13, and hit enter. So this company will accept any measurements as long as they're not lower than 3.72. And right now we're looking at this data, none of those are lower than 3.72. So all of their samples are okay. Then we need to find the maximum acceptable depth as well. The maximum acceptable depth is the same thing. It's equals the mean, but it's plus 2 standard deviations this time. So again, I'm telling it to take the mean, which is located in E4, and add 2 sample standard deviations, which is located in E13. So the maximum acceptable depth that this company will accept for these connectors is 4.41. Anything above that they would have to throw out. All right, now that we have all of our statistical analysis done, the next thing we're going to do is create a histogram. Now, before we can create a histogram, we have to create intervals for the x-axis. And the way you can do that, by the way, Excel calls those bins, so we're going to label this bins. And on our histogram, we need to figure out over here on our data what our smallest number is and what our largest number is, and then kind of make a reasonable interval to go from 3.8 to 4.4. So our bins need to start at 3.8, and then I've got to decide, do I want to count by 0.1s, 0.2s, 0.5s? If I count by 0.5s, that doesn't make sense because it only took me 3 bins to get all this data in there. So I don't want to count by that much. 0.2s might be okay. I could add 2 to everything, so it'd be 4.0, 4.2, 4.4, but again, there's only 4 bins. So in this case, I might just want to count by 0.1s. Now, it just happens to be that the bins in this set of data is going to be the same numbers as what I have in my data. That won't always happen. So this is going to make a better histogram because I've got 7 bins. You really want your bins there to be set between 7 and 10. Now notice I didn't put every single number in there. I'm just telling Excel what I want the histogram to get counted by. Alright, now that I have the bins set up, I'm ready to run my histogram. So I'm going to go up here to data and I'm going to run data analysis. Now if this button is not available for you, you're going to have to install it. And the way to install that is to go to File, click Options, click Add-ins, and then right here beside of Add-ins, make sure this says Excel Add-ins and hit Go. And you want to make sure that this first one is checked. Once it's checked, hit OK, and then your data analysis should show up. So again, I hit the data tab, and now I'm going to hit data analysis here. And I want to do the histogram. So double click your histogram. Now we've got to fill in these boxes here. Our input range is our data. So you click the red arrow, highlight your data, then click the red arrow again, and you can tell it says it's B5 to B16. So that was where I highlighted my data. Now my bin range is what I just created. So click the arrow beside of that and highlight the numbers there, 3.8 to 4.4. Click the red arrow. I do want labels, and then I want it to be a new worksheet. And then I also want a chart, so I'm going to click the chart output, and then I'll hit OK. So there's your histogram. Now I don't like this because this is not really a histogram, so I can change this so it really is. It's not a histogram because the bars aren't touching. This is really a bar chart. I don't like that Excel tells you that. Now you can tell my titles aren't right. This title right here should be the depth in centimeters, so I'm going to change that. I just double clicked that to change it, and I can hit escape and get out of it. And the frequency, that's correct. If we go back to our table, it's not really the frequency, it's the yeah, that's the frequency. That's how many there are, how many 3.9s there are. There are 2 of those. There are 3 4s. There are 3 4.1s, and so on. Now if you don't want this legend, you can just delete that. That's not necessary. Now to change these bars so that they touch, click on the bar, and then if you're not seeing this over here, once you click on it, you can right click and hit Format Data Series, and then make sure the bars are chosen here, and change your gap width to 0. Okay, and that will be a histogram now since the bars are touching. Okay, now a couple questions here. I'm going to add a new sheet and we're going to talk about some questions. First question is this data normally distributed? in order for this data to be normally distributed, the mean needs to be my highest bar. So I need to go back and look and see what my mean is. My mean is 4.07, and if I look at my histogram, this bar is 3.9 to 4.0. The next bar is 4.0 to 4.1. No, I said that wrong. This bar is 3.8 to 3.9. This number is what it ends in. So 3.8 to 3.9, then 3.9 to 4.0, 4.0 to 4.1, and 4.1 to 4.2, and so on. So this number down here is what the bar ends in. So my mean is 4.07, which means it's going to be in this bar right here, because this bar is 4.0 to 4.1. So 4.07 would be here. So my mean is in my highest bar. And then the next thing I would need to know is if it is in my highest bar, do the bars on either side of the mean go down? Well, not on this one, because this really needs to make more of a bell curve. So in order for this to be normally distributed, the shape of this histogram would need to look more like this. It would need to go like that, with the mean bar being in the middle as the highest bar, and then the bars on either side of that going down as you go, like that. So our shape is kind of up and then down like that. Our mean is here, kind of skewed to the right, and then it's not going down there like it's supposed to be. It's kind of coming over and then down. So our data is not normally distributed here. So if we were answering that question, we would say no, because even though the mean is the highest bar, the data does not go down on either side of the mean. Okay, so our data is not normally distributed. The other thing that they're probably going to ask you when you get ready to do 3.9 is they're going to ask you for a compound inequality, and also for a plus and minus notation. Okay, they're going to ask you for those two things. I want to go back to the data sheet and show you that. So let's do plus and minus notation first. So plus and minus notation is basically you're telling everybody how you came up with this minimum acceptable and the maximum acceptable. So remember what we did is we took our mean, which in this case is 4.07, and we added and subtracted 2 standard deviations. So this is where you're going to put the plus minus. So I want to put a plus sign, but I want to underline it so it looks like a plus minus. So hit Control U to underline, then type a plus, and so see that looks like a plus minus. And then hit Control U to turn your underline off, and then type in 2 standard deviations, so 0.172. So we're telling everybody, hey, how I got this minimum and maximum acceptable is I took the mean, 4.07, and I added and subtracted 2 sample standard deviations, which is there, 0.172. Now, compound inequality is just a way to write your minimum and maximum acceptable depths. So this is your compound inequality. So compound inequality is you put your minimum first, 3.72. Then remember, an inequality is like less than, greater than, and so on. So I'm going to underline that because I want it to be less than or equal to. So I Control U and then type a less than, so it underlines. Then Control U again, hit an X, Control U, to turn your underline back on, another less than symbol, Control U to turn the underline off, and then 4.41. And that's your compound inequality. So it's these numbers right here is what I used for my compound inequality. So this tells everybody that, hey, my depth, by the way, that probably should be Y. Oh no, it is the X because our X-axis is the depth. But so our X-axis can be between 3.72 and 4.41, and those are the measurements that we'll accept. So at this point, I'm just going to copy and paste those. So I'm going to Control C is copy, and then if I want to just paste that under there, Control V is paste, and then I can Control C and then Control V. The next question that you might have to answer is how many connectors would you expect to be accurate or to be acceptable? Well, because we're using 2 standard deviations, we expect 95% of our data to be acceptable. So this time, since we have 12 pieces of data, 12 different data points, we would expect 95% of 12 to be acceptable. Okay, now 95% of 12 is 0.95 times 12. So we would expect 11.4 of those, or 11, since we can't have 11.4 samples. We would expect 11 of those to be acceptable. All right. Now, in our case, how many were acceptable? In our case, all 12 were acceptable because none of them were below this 3.72 and none of them were above 4.41. In fact, our largest one was 4.40. So all of our data, all were acceptable. All 12 were acceptable. Now, when you get ready to measure your puzzle cubes, you're going to have to figure out what your minimum measurement, what your maximum measurement is, and then you're going to have to figure out how many are acceptable, and you may have to throw some of them out, or you might get lucky like this and all of them be acceptable. Okay? Now, the reason those numbers are different is because one is an estimate and the other is the actual. Okay, those numbers will be closer together if you had more samples. Okay, so what I mean by that is if we actually took more than 12 samples, let's say we took 100 samples, then we would expect that our prediction of how many were acceptable and how many actually were acceptable, we would expect those two numbers to be closer together. But this wasn't too far off. That was only one away. Okay, that does it for 3.7. So you can use this to go ahead and submit this on the mypltw.org, and then you can use this same thing to help you finish up on 3.9.